Good morning, good afternoon, good evening, wherever you are in the world. We are delighted that you can join us here for an outstanding webinar this afternoon, at least this afternoon my time, on using AI to amplify the accuracy of human forecasting by Dr. Louis Rosenberg. My name is Hugh Morris. I'm a senior research partner at Zien, and it's my great pleasure to be able to chair this event today, which I can only do thanks to the generosity of our sponsors. And the sponsors allow us to range widely and freely across technology, economics, and finance. Now, my job is to get out of the way as quickly as possible and hand over to our speaker. Some housekeeping notes, though. The slides are available to download in the chat and on the website. We will be holding a 20-minute Q&A session after Louis' presentation, so please make sure to use the GoToWebinar chat facility to send your questions into me. I will then feed them into the conversation. Please also accept our apologies for the gremlins having got into the system and us therefore starting 15 minutes late. Thank you very much for your friends. So, without further ado, Louis, the floor is yours. Thank you.
Great. Next slide. Yeah, thank you. So I'm Louis Rosenberg, founder of Unanimous AI, and we are a very different type of AI company. While most AI companies are out there aiming to replace people with algorithms, we use AI to connect groups of people together and make them smarter. Next slide. So today I'll be talking about using AI to amplify the accuracy of human forecasting, which you can imagine has lots of applications from sales forecasting, financial forecasting, market research, engineering, medical. Our technology is even used by the United Nations to forecast famines, which I'll talk about a little bit. Next slide. So here's a quick outline of what I'll be talking about today. I'll talk first about the technology, which is called swarm AI, and it's based on the biological principle of swarm intelligence. And it uses AI to amplify the intelligence of networked human groups. Then I'll talk about some validation studies, some published studies that were conducted with MIT, Oxford, Cambridge, Stanford, to talk about the proof that this method works. And then I'll talk about some applications in financial forecasting, sales forecasting, sports, handicapping, equity speculation. Hedge funds use the technology to forecast equities, and even medical diagnosis. Next. So let me start out with a controversial statement in the world of AI, namely that people are smart. Everybody who's logged into this webinar right now has a vast database in their head of knowledge and wisdom and insight and experience and intuition, and most AI systems cannot access that. They can't access the human database. And the thing that really inspired me a decade ago to focus on this topic was this question of, well, how can we best harness and amplify the intelligence, this vast intelligence of human groups? Next. And the place that I started was where a lot of technologies start, which is by looking at nature. How does nature do it? And it turns out nature has been working on this issue for hundreds of millions of years. And if you think of, for example, a school of fish, there's thousands of fish. Each one has a slightly different view of the world, slightly different information about the world, slightly different historical experiences, slightly different personality. And all these thousands of fish with these different views work together and enable the school to function as a superorganism that could navigate the ocean and survive, and is actually significantly more successful than any one of those single fish could be. And so the question is, well, how does nature do it? Well, what nature does not do is nature doesn't take votes or polls or surveys. There's no survey monkey in nature. Nature doesn't analyze big historical data sets. There's no big data and machine learning in nature. What nature does is it forms systems, real-time systems with feedback loops that enable groups to converge on optimal solutions. And so biologists call this swarm intelligence, and it's why birds flock and fish school and bees swarm. They are smarter together than alone. And so the question is, well, if birds and bees and fish can get so much smarter as swarms, why can't people do it? Next slide. And it turns out that we can, if we use the right technology. And so there's two images here. They're a little choppy. I apologize. It's just because we're over webinar. Normally they would look very smooth and natural and organic. But the key thing here is that first you see a natural swarm, and my team at Unanimous AI, we've been studying natural swarms for the last 6-7 years and developing the algorithms and interfaces that allow humans to form similar swarms online. And so this image that says artificial swarm, each of those little yellow magnets you see is controlled by a person logged in from anywhere around the world. And by using their mouse or their touch screen or their phone, they're moving their magnets to pull on that glass puck. And in this case, they're answering a financial question. They're forecasting the likelihood that the S&P 500 will increase over the next 30 days. And what's happening is that they're all behaving together in real time. And there are AI algorithms watching all of their behaviors, watching how they're interacting, and controlling how the swarm moves. And so a swarm is a real-time system with participants acting and reacting and interacting, revealing the strength of their convictions to the underlying algorithms that control the convergence of the group sentiment. Next slide. And so the technology working behind the scenes is called swarm AI. And so the key thing to understand is that what you see, what a participant sees, is very simple. All you have to know is how to use a mouse or a touch screen and control this magnet. What the AI sees is this cloud of behavioral data that's being updated every 200 milliseconds. And so swarm AI is analyzing the human sentiments in real time and finding the optimal combination of the group's wisdom based on their varying confidence. Next slide. And so you could think of swarm AI as a system where you start with a networked human group of people who have knowledge and wisdom and insight and experience about some topic. You connect them together with AI algorithms and you turn them into an artificial expert that you could then ask questions to and generate significantly more accurate forecasts, estimations, assessments, decisions, predictions. Next slide. So the question, of course, I'm sure you're wondering, is does it work? And so I want to talk about some academic studies that have been done by major universities around the world. Last year, we published a study with MIT that looked at using swarm AI for making financial predictions. And so we had groups of financial traders who were logged in from different locations, and they'd come together and they'd forecast weekly the price of gold, the price of oil, and the S&P 500. It was about 20 participants each week, and they did it every week, making weekly forecasts for 20 consecutive weeks. They did it alone. They did it as by taking a vote, a majority vote, and they did it as a swarm. So 3 conditions. And what the published study shows is that when they worked together using swarm AI, they were 26% more accurate than their traditional method. And I should mention all these papers are actually on our website at unanimous.ai. You can actually see the published studies. And so again, we saw this really significant increase in performance. We published a study also last year with researchers at Oxford University looking at just regular sports fans. We brought together a group of 20 or 30 regular sports fans, and we had them work together as a swarm to predict 50 professional English Premier League games. So it's 10 games a week for 5 consecutive weeks. They predicted all the games. They predicted it as individuals. They predicted it by taking a majority vote, and they predicted it by using swarm AI. They're working together as a swarm. And what you can see is as individuals, they were 55% accurate in predicting the outcome of the games. When they took a vote, they were 58% accurate, so they were a little bit more accurate. A lot of people refer to that as wisdom of crowds. When they worked together as a swarm, they were 72% accurate, a massive increase. And it goes to this point that, well, swarms really are more accurate than crowds. We did a study with California Polytechnic where we looked at 60 business teams. And these were small teams of just 5 or 6 people. And they were given a standardized subjective judgment test that's used in a lot of different studies. They did it alone, they did it by voting, and they did it as a swarm. When they took a vote on this test, they were a little bit more accurate, reducing their errors by 9%. When they worked together as a swarm, they reduced their errors by 52%. Again, showing this really significant increase in accuracy when you aggregate their input as a swarm. And then finally, last year, Stanford Medical School published a study, actually in the journal Nature, Digital Medicine, where they looked at swarms of doctors making diagnoses. In this case, they were radiologists, and it was just 5 or 6 radiologists. They'd each be sitting at their own desk. A chest X-ray would pop up on their screen. Swarm interface would pop up on their screen, and they would make the diagnosis. And what the study found was that then when they worked together as a swarm, they reduced their diagnostic errors by 33%. Compared to making their diagnoses alone or by taking a vote. And this was really a really surprising study to us because the groups were so small, but also because these were experts. These were people who had gone to medical school for 4 years and then specialized and then interned. And these are highly trained people at the top of their field. And still, when they worked together as a swarm, they could reduce their errors by a very significant amount. Next slide. So how does it actually work in practice? Let me just go through just a typical real world example. One of the things we do at Unanimous AI is we work with journalists very often to generate forecasts for things. For a few years in a row, Newsweek asked us to predict the Oscars using swarms. Next slide. And so what we did was we just used regular movie fans, not experts, not movie critics, just regular movie fans that we found over the internet. So 50 regular movie fans, we paid them each $1 to participate. All they need to participate in a swarm is a standard browser. They log into our software that's just called Swarm. They do that by getting an invitation. We just send them an invitation by email or text or a Slack message. And once they log into Swarm, they enter a workspace that looks like this. Next slide. And so what you can see here is that there's an area where a moderator can chat with the group. There's an area where you can share media, pictures, video. There's an area where you can see who the participants are. But the important area is this central area, this red area, where the groups swarm. And that's where we ask questions and answer questions. Next slide. And so very often when people use Swarm, they zoom in on this, and this is forecasting the Oscars. So there's an area where questions appear, who's going to win Best Picture, an area where answer options appear, all the different movies that were up, and then each person can control a magnet. And they control their magnet, again, using their mouse or touchscreen, and they just have to answer the question. And so what does it look like when you have 50 randomly selected movie fans answer a question like Best Picture? Let me show you. Next slide. So here you have the 50 people. They're all working together, pushing and pulling on this glass puck. There are, again, AI algorithms watching all of their behaviors, determining how to best combine their sentiments. And in this case, they go and they selected Shape of Water for Best Picture, which actually wasn't the favorite. And this was actually a pretty interesting example of how this swarm performed. But we then asked this. We asked all the questions to the swarm, and for all of the different movie categories, we gave it to Newsweek, and here you can see how did we do. And you can see that the Oscars, the swarm was 94% accurate in predicting all the categories. We outperformed Variety magazine, the LA Times, Vanity Fair, which were all done by professional movie critics. We outperformed Gold Derby, which is a big crowdsourcing site where hundreds of thousands of people just vote. We outperformed Bovada, which is a Vegas betting site, a betting market, which is also a different way of aggregating groups, and Rolling Stone. And we see this year after year. And again, this was just 50 randomly selected movie fans, and they were able to outperform the top movie critics in the world because people are smart. People are smart, and if we combine their input in optimized ways, we can get these remarkable forecasts. Next slide. And so why does it work so well? Well, it's important to just take a step back and just realize that there's a feedback loop happening here. There's the front-end interface. That's what people see. That's very easy to use. People find it fun. And then there's this AI backend that's watching everybody's behaviors. And the key thing to know is that a question pops up on everybody's screen. Everybody immediately reacts to that question. The AI algorithms see all the reactions and starts to move the puck. But as soon as the puck starts to move, everybody reacts to that. They change their behaviors. And as soon as they change their behaviors, the AI algorithms updates how it's aggregating all of their input. And so what you have is the people are influencing the AI is influencing the people, and they converge together on these really good combinations of their knowledge and wisdom and insight and intuition. Next slide. And so you can imagine, a vast array of business applications, any place where you're going to have a group of people who have knowledge and wisdom and insight, and you want to make optimized forecasts, decisions, evaluations, predictions. And for most of the companies that we work with, they really think about it two ways. There's internal teams and external teams. On the internal team side, you could imagine you have groups of people who are experts, and you can have a sales team, and they can work together as a swarm and very quickly generate optimized sales forecasts. We work with lots of marketing teams that generate lots of forecasts about whether marketing messages will work, whether branding messages will work, engineering teams forecasting how long things will take, how much things will cost, financial teams, executive teams making executive decisions, HR teams making hiring decisions. We also see lots of customers and companies using external teams. They work with their customers, they work with distributors, they work with their influencers. And so we've seen lots of companies that will bring together groups of their customers and generate insights from their customers that help them run their business. Next slide. And so this is just some of the companies that have been using Swarm for wide ranges of applications, lots of companies around the world. I can't talk about most of these applications because lots of companies, what they're doing is confidential, but there's a few I can talk about, one of which is the United Nations. And so actually really interesting application. And so the United Nations has been using Swarm AI for almost a year. Next slide. And what they do is they're using it to forecast famines around the world. And so there's a group inside the United Nations called the Food and Agriculture Organization, or FAO, and they have a group of experts who predict the food insecurity risk of various nations. And these experts have different expertise. Some might be experts in climate issues, some experts in political issues, some experts in food supply chain, because there's lots of different issues that go into the food insecurity risk. These experts are located around the world, all in different countries, and it's a high stakes decision. Based on these assessments, relief agencies then decide how much aid to give to different nations. And so the United Nations has been using Swarm to do this. And the way they generally do it is they have about 20 participants that connect remotely from a dozen different countries at once. And then they assess the risk of various nations on a scale of 1 to 5, from food abundance to likely famine. And when they first started using Swarm, this is a year ago, they did a pilot study to compare how does Swarm work compared to their traditional methods, because they wanted to be really sure it was a good replacement for how they were doing it before. And so they ran this rigorous study, and what they discovered was a few things. First, they discovered that I should mention that their traditional method is to bring this group of people together in the same room, sit around, and through a rigorous process, basically discuss and argue about it and come to a decision. With Swarm, they're able to do this remotely, and it turns out they're able to do it much, much faster. So they're able to reach equally valid decisions as their traditional process, but do it much faster. But what they also found was that their participants were, they liked it better because everybody is equal and everybody's anonymous. And in any organization, whether it's a Fortune 500 company or a public a public organization, there's generally a hierarchy. There's generally politics. People don't necessarily speak their mind freely. They feel like they have to second guess what their boss wants them to say. When they're inside of a swarm, you can see what everybody's doing by seeing the magnets, but you don't know who is who. Everybody's equal. Everybody's anonymous. People feel like they can give their opinions more freely. They also feel like they can reach outcomes faster. They also reported having greater buy-in to the answer because they could observe in real time how the group converged on an answer. Very often, organizations will just send out a survey. People will drop answers into a survey, and if it doesn't come out the way you wanted, you feel like, well, nobody cared what I thought. In a swarm, everybody is experiencing the coming together of the decision in real time. They have this greater buy-in, and so it was a very, very successful tool for the United Nations for this application. Next slide. I'll give one last example, which is sales forecasting. A lot of our customers use Swarm for those types of things. This is an example from a large clothing retailer, Fortune 500, S&P 500 company. They wanted to predict holiday sales of women's sweaters. So they had a group of women's sweaters. In this case, you can see 8 sweaters on the screen. And their normal way would just be to put out a big poll, a whole bunch of people to try to predict which of these sweaters will sell the most, which of the sweaters will sell less. And they do this so they can predict inventory. And so it's obviously, if you can predict the different sales levels, it's a huge value. And so this particular company did a study to compare a traditional survey to Swarm, which is actually a case study that's on our website you can look at. And the goal was to predict the best versus the worst sellers. And they did this in Swarm with just 45 people. These were just selected off of the internet as fashion-conscious women, and they did it in 3 groups of 15, so 3 swarms of 15. Next slide. This is what it looked like. So the question popped up on their screens: which style will sell the fewest this holiday season? And that's interesting. And you can see we asked the question in reverse: which will sell the fewest? And they could see the pictures of all the sweaters, and they would choose an answer. And then once they picked the one that would sell the fewest, we remove that one from the set, and then ask the question again with the remaining ones: which one will sell the fewest? Asked again. And so here you can see the swarm actually doing one of these answers, converging on an answer. Next slide. And again, it's worth mentioning that while it looks simple in the front end, the AI engine is seeing all the behaviors in real time and combining all the insights. And of course, the big question is, well, how did the swarm do? Next slide. And so they ranked these sweaters from 1 to 8. And then this was an actual study where they had the real answers that came out after the holiday season. And you could see that the sweaters that the swarm ranked as first and second sold $1.7 million worth of sweaters. The ones that ranked 7 and 8 sold 600,000. So it's really good ranking. And again, it was just done with 45 participants. So from a study perspective, it's very, very small. And they also compared this to the poll, to their large scale poll. Next slide. And so how did the survey do? You can see that the top 2 sweaters compared to the bottom 2 sweaters. Their top 2 sweaters sold 1.4 million. The bottom 2 sold 1.5. So they actually didn't rank them in a effective way. And the study showed that the top 4 chosen by the swarm were 23% more accurate than the top 4 chosen by the survey. Next slide. So closing thoughts, just to give you the mental model, Swarm AI is a technology where you start with networked human groups, people who have knowledge and wisdom and insight and experience. We connect them together in real time. They can behave as these artificial experts that generate significantly more accurate forecasts and estimations and assessments. Next slide. And good way to think about forecasting using this technology is it's optimizing the combined knowledge and wisdom and insights of the group. It's amplifying the accuracy of forecasts and assessments and decisions. It's speeding the deliberation of the group. It's reducing these social barriers, especially when there's a hierarchy. Everybody's equal, everybody's anonymous, and it promotes buy-in from participants. Next slide. And with that, happy to open it up to questions, and my contact information is provided as well.
Lewis, outstanding. Thank you so much for those insights. I don't know about anyone else, but I was carried along by the whole thing. It seems absolutely amazing. We have got some great questions. So I'll just kick off with those, if that's okay, Lewis. The first one from Al S says, does it matter who's included in the swarm, or do more diverse and inclusive swarms perform better?
Yes, it's a great question. So the thing that we've discovered over the years is that if you take a group of people and you put them into a swarm, they will be smarter together than they would be alone. So if you take a group of novices, you'll get an expert. If you take a group of experts, you'll get a super expert. And so so it works with groups of people from randomly selected members of the public to experts in particular fields. That said, if you have a particular thing you're trying to solve, you want to get participants who have some level of knowledge and wisdom and insight. If the people are just guessing, we can't amplify their intelligence. But if they have some level of intelligence, we can significantly amplify that. In addition, we found that diversity really helps. So having groups of people who have different perspectives, different backgrounds, different expertise will lead to smarter swarms than if you have groups of people who all have very, very similar backgrounds and similar expertise.
Tremendous. John Spain asks, does the success have anything to do with subjects veering towards a central view and away from extremes?
So it's, I would say that the success is more about participants revealing their true levels of confidence or conviction. And I use these two words, confidence and conviction, because if I ask you to forecast something, it might be what's your confidence in that forecast. If I ask you your sentiment, it might be your conviction in that sentiment. And they kind of overlap. But the place that a lot of systems fail that try to capture and aggregate information or from humans is that it's easy to ask somebody their opinion. It's really hard to know how strongly they really believe in their opinion. And if you ask somebody to tell you on a scale of 1 to 10, how strong do you believe, who do you think is going to be the next president of the United States? You can give me an answer very easily. How strong do you believe that? You can give me a number, but if you say you believe that as a 7 out of 10 because you did it on a survey, your 7 might be somebody else's 3. Like people have different scales, people are non-linear, but when they work together as a swarm, we're actually not asking them to report how they feel, we're asking them just to behave. And so the AI algorithms are watching their behaviors and are inferring from their behaviors the true level of sentiment. And so what we're really doing is we're getting a better combination of all the different perspectives because we have a better sense of who really believes their opinions or who feels strongly, who doesn't feel strongly, based on how they're behaving and interacting in real time. And because of that, we get to what the question asked, which is people will veer away from these extreme views because they might think they're supposed to have an extreme view, but they might not really believe that extreme view, or their view might not really be as extreme as they would normally just put on a survey. And so it does, especially when we ask politically charged questions, which are some of the hardest, we end up getting answers that are much more accurate than a survey. In fact, we were asked to predict the presidential elections last year, battleground state by battleground state in the United States. And so there were 12 battleground states that were toss-ups, and we did it with swarms of people, and they predicted every single one correctly, even though the polls had most of them wrong. And again, it's because polls are polarizing. A poll forces people to take the extreme views, whereas a swarm is the opposite. It's asking to reveal where people agree as opposed to reveal where people disagree. And it gives you more accurate insights, and it gives you better decisions.
Stuart Jack, or Jack Stewart, forgive me if I've got that the wrong way around, asks, are the swarm participants, presuming this is in a commercial environment, normally in-house staff members or members of external focus groups?
So both. And so we see both happening all the time. We will have, like, for example, the United Nations, those are in-house experts for the United Nations. But there are lots of other examples where companies will use outside people. There's a basketball team in the US, the Miami Heat, they're a customer, and they wanted to optimize their season ticket offerings, the perks that they offered their season ticket holders. Sure. And so they can do that with their internal team, but instead what they did was they brought in.
Next question, the participants, the movement. Sorry, Lewis, I cut you off. Let me let you finish.
Oh, no, you were breaking up as well. Oh, I was saying, so they're they use their season ticket holders to help them forecast what would be the best offerings to get people to sign up again for another season. But again, we see lots of use of members of the public in, as you would in focus group, and lots of applications where it's members of internal teams. And I'll give one other example for internal teams. We work with hedge funds, and they will have their internal analysts work together to forecast equity prices. And what they find is that they are much better at forecasting equities when they work together as a swarm than when they do it as individuals in their traditional method.
Well, that probably leads on to a great question from Roger Ramsden, who says, I'm a little confused about the feedback to the participants about the movement of the glass. How does this feedback influence individual responses in the here and now?
Right. So everybody is watching and experiencing in real time. It's actually very smooth. I know it's a little choppy on the screen in webinar. You can go to our website. You can see what it really looks like. But what's happening is, and the replays were a little bit sped up. They let each replay, each decision happens in under 60 seconds, so it's fast. But what happens is somebody will start pulling towards answers, and as the swarm starts to move, they're all updating and moving their magnets in real time. If they really believe in an answer, they will be entrenched. But it's not just a vote. The puck is moving, so they have to chase the puck with their magnet. If it's moving away from them, they might decide that at some point it's moving away from them. They know it's not going to go to the answer that they want. They'll switch to another answer. And so what you have is all these people are they're either being entrenched, they're being flexible, they're changing their answers. Some are changing their answers right away. Some are taking longer amounts of time, but they're all revealing these different complicated behaviors, and that's influencing how the AI is actually moving the puck in real time, and it's enabling the group to converge on these very, very good solutions.
Ian Sheridan asks, from a groupthink viewpoint, external teams using Swarm AI has massive potential to check an internal team's judgment. How can your company, Lewis, explain the reasoning behind how the AI swarm reaches its decisions?
Right. So, I mean, this interest, you brought up the issue of groupthink, and very often people say, well, if you work together as a swarm, if it's an internal group, will it lead to groupthink where everybody just thinks the same thing, or everybody just follows the leader? And it's valuable to point out that in nature, there's really two very different structures. There are herds and there are swarms. And a herd is really a good example of groupthink. A herd is one where if you startle a cow and that cow starts running, all the other cows will follow. A herd is really a leader-follower model. A swarm is different. A swarm is this parallel structure where there are no leaders, there are no followers, everybody is interacting at the exact same time. And as a result, you really see answers that are not, instead of having this kind of groupthink emerge, you actually have people who come out of the experience feeling like, they explored diversity of opinion, everybody was heard, and they achieved the answer that they could best agree upon, which is really, really very different than how a lot of decisions are made.
Angel Gaviero asks, not sure if I get the concept. Traditional AI combines past big data to learn the patterns and then applies for real. Swarm AI looks like it does not look at past patterns, just alive to the reaction of the actors. Is that correct?
Yes and no. And so, so our system is trained on past data, but it's not trained on data about the questions. So it's trained on human behavioral data. And so what that means is we've had hundreds of thousands of questions answered by swarms of people. And so our algorithms that are running in real time have learned how to determine from the various subtle motions that people are making, when they switch, how they chase the puck, how they defend against the puck going to an answer. It's learned how to interpret all those behaviors to assign confidence or conviction. And so what's really different is that if you were, in finance, traditional hedge funds might use AI and train that AI on market data, on interest rates, on earnings reports, and then try to make inferences about the future. Our system is trained on human behavioral data, and then we bring together a group of experts, and it will use their knowledge and wisdom and insight, but combine their insights in an optimal way. And the real value of doing it this way, where we're taking advantage of the human knowledge and wisdom, but the power of AI, is that there are a lot of questions in the world where historical data in the traditional machine learning methods don't work. They don't work because you might have sales data about the holiday season last year, and you might use that with your AI system to predict this year. What you're really doing is predicting how your sweaters would have sold last year. You're not predicting how your sweaters will sell this year. Humans are continually collecting data. We have a sense of all of the contextual issues that are going on in the world. We have a sense of, what does the market feel like this year? What are the current market conditions? And so people are really good at making forecasts with incomplete information, but when we combine their insights together, they become super experts. And so for questions where human insight and human knowledge and human intuition is valuable, swarm AI is really, really powerful. For questions where the past really predicts the future very well, like weather forecasting, traditional AI is great. But a lot of people are trying to use traditional AI to predict things that really aren't predictable based on historical data, especially if there's humans involved.
So I think I have time for one more question, and Al S., thank you very much for a whole series of questions you sent in, all of which are great, but I'll pick this one. Would Dr. Rosenberg be able to discuss how this has changed his decision making in his life? What about human behavioral data versus other creatures' behaviors?
Yeah, so I've certainly gotten a really profound respect for people, for human knowledge and wisdom and intuition, and also really profound respect for gathering input from lots of people. Meaning, I've found that being able to capture and aggregate, the perspectives of lots of people is really, really helpful. In terms of how we work inside our company, we use our own technology to make decisions. We use our own technology to make forecasts. It's been effective for us, and we're continually testing the technology, pushing the technology every day. We do lots of forecasts, from financial forecasts to marketing forecasts, even to sports forecasts. We're currently doing forecasts in the UK for all of the entire English Premier League season right now. We predict every single game, and just using groups of random sports fans from the UK, and season after season, we outperform the Vegas odds makers. So it convinces us of the power of human intelligence.
And there's a very good example of the value of this information. I must sign up to the service. This has been a great session on a fascinating topic. I mean, AI in all its dimensions is clearly going to change most things we do in life radically. And Lewis has given us great insights into one aspect and one fascinatingly new way of looking at it. Thank you very much indeed, everyone, for attending. I would also like to thank the sponsors once more, because without them, this would not be possible. And what a discussion and a presentation we would have missed out on. Thank you very much to all of you for listening. I would commend to you a series of equally interesting events coming up that you can see on the screen now, and you can find on the FS Club website. Thank you so much for your time and attention. And Lewis, thank you so much for a really, really engaging discussion and presentation on this subject. I thank you all, and good morning, good evening, good night, wherever you may be.